let's give you a really cursory crash course in deep learning and how deep learning intersects with the world of AWS. Now, you're definitely not going to be expected to be a deep learning expert for the purpose of the exam, but you will be expected to recognize the basic types of neural networks that are out there and how to best set these up on AWS. So let's just talk about what deep learning is all about in neural networks. I mean, it's all pretty amazing stuff, really. The whole field of artificial intelligence is based on an understanding of how our own brains work. Over millions of years of evolution, nature has come up with a way to make us think. And if we just reverse engineer the ways that our brains work, maybe we can gain some insights on how to make machines that think as well. Now, within your brain, specifically within your cerebral cortex, which is where all of your thinking happens, you have a bunch of neurons. These are individual nerve cells, and they're connected to each other via axons and dendrites. You can think of these as connections, wires, if you will, that connect different axons together. Now, an individual neuron will fire or send a signal to all of the neurons that it's connected to when enough of its input signals are activated. At the individual neuron level, it's a very simple mechanism. You just have this neuron that has a bunch of input signals coming into it, and if enough of those input signals reach a certain threshold, it will in turn fire off a set of signals to the neurons that it in turn is connected to as well. But when you start to have many of these neurons connected together in many different ways with different strengths between each connection, things get very complicated. This is a perfect example of emergent behavior. You have a very simple concept, a very simple model, but when you stack enough of them together, you can create very complex behavior that can yield learning behavior. This actually works. Not only does it work in your brain, it works in our computers as well. Now think about the scale of your brain. You have billions of neurons, each of them with thousands of connections. That's what it takes to actually create a human mind. And this is a scale that we can still only dream about in the field of deep learning and artificial intelligence, but it's the same basic concept. You just have a bunch of neurons with a bunch of connections that individually behave very simply, but once you get enough of them together, wired in enough complex ways, you can actually create very complex thoughts and maybe even consciousness. The plasticity of your brain is basically tuning where those connections go to and how strong each one is, and that's where all the magic happens. Furthermore, if we look deeper into the biology of your brain, you can see that within your cortex, neurons seem to be arranged into stacks or cortical columns that process information in parallel. So for example, in your visual cortex, different areas of what you see might be getting processed in parallel by different columns or cortical columns of neurons. Each one of these columns is in turn made of mini-columns of around 100 neurons per mini-column. Mini-columns are then organized into larger hypercolumns, and within your cortex there are about 100 million of these mini-columns. So again, they just add up very quickly. Now coincidentally, this is a very similar architecture to how the 3D video card in your computer works. It has a bunch of very simple, very small processing units that are responsible for computing how little groups of pixels on your screen are computed. It just so happens that that's a very useful architecture for mimicking how your brain works. So it's sort of a happy accident that the research behind your favorite video games lent itself to the same technology that made artificial intelligence possible on a grand scale and at low cost. The same video cards you're using to play your video games can also be used to perform deep learning and create artificial neural networks. Think about how much better it would be if we actually made chips that were purpose-built specifically for simulating artificial neural networks. Well, it turns out some people are designing chips like that right now, and by the time you watch this, they might even be a reality. I think Google's working on one as we speak. Now, we've translated these ideas into artificial neurons. An artificial neuron just sums up the weighted inputs from the layer above them, applies some sort of activation function to that weight, and passes the result up to the next layer. Think of it as just another machine learning model. You input feature data at the bottom or attributes at the bottom of the neural networks, and predicted labels come out of the top, usually a classification of some sort. The network is trained using data with known labels. During the training process, it figures out the ideal weights between each neuron to get the right answers at the top. The details aren't really important for the exam. There's a lot of depth we could go into how it gets trained and how backpropagation works and gradient descent and all this stuff, but you don't need that for the exam. The only thing you need to know is that it's called deep learning because there's more than one layer of neurons here. Basically, it's stacked up layers of neurons connected together in different ways, and those weights between each neuron are what form the basis of your neural network. Neural nets tend to lend themselves very well to parallelization, and individual neurons are simple enough to be modeled as units on a GPU. So a GPU can parallelize the processing of lots and lots of neurons, and you can have many GPUs on a single node in a cluster, and you can have many nodes in a cluster. So this scales up pretty much infinitely. You can actually start to think about building things on the scale of building a brain of your own. Now, there are some deep learning frameworks out there to make developing these neural networks really easy from a coding standpoint. One is TensorFlow from Google, and another one is MXNet from Apache. So these are both popular frameworks for developing deep neural networks that can be parallelized across a cluster. Here's a little code snippet of some TensorFlow code that does just that. This just sets up a layer of 64 input neurons at the bottom where you're feeding in your input features. There's a hidden layer there of 64 neurons in the middle as well. And at the top, there's a layer of 10 neurons that actually output the final classification of one of 10 different things. So you can imagine maybe there's a 8x8 array of pixels going in here at the bottom of the neural network, and out comes an array of one of 10 classifications. The rest of the code is just talking about how that model is trained exactly. And again, you'll never be expected to actually write or read code on the exam itself. I'm just providing this to make it more real for people who do understand code. And again, you're not going to need to know the details of how the different kinds of neural networks work. You're just going to have to recognize these terms and know that they are kinds of neural networks, and at a very high level what they do. So for example, we have a feed-forward neural network. That's the ones that we just looked at previously in this lecture. That's an example where we just have a very simple neural network where we feed in attributes at the bottom and classifications pop out at the top. Now you can make more complex neural networks such as convolutional neural networks, also known as a CNN. These are neural networks that are purpose-built for processing image data, either 2D or 3D image data, and typically they're being used for image classification. So for example, if you have pictures coming in from a camera on your self-driving car, you might need to know if there's a stop sign in that image somewhere. A convolutional neural network is capable of doing that. It can look at all the different parts of that image all at once, and if it sees something that looks like a stop sign, it can output that at the top of the neural network. Another kind of neural network is called the recurrent neural network, or RNN. Recurrent neural networks are designed to deal with sequences in time, and that's what's actually illustrated here on this slide. You can see that in addition to the outputs of the individual neurons being propagated upward to the next layer, they also propagate back to that same layer again in the next iteration. And in this way, it can model the effect of time passing as it's being trained. So an RNN is appropriate for dealing with things like predicting stock prices or understanding words in a sentence and things like that, where the sequence is important. There are some specialized kinds of RNNs, including LSTM, that stands for Long Short-Term Memory Cell, and also GRU, which stands for Gated Recurrent Unit Cell, which is just a simplified version of LSTM. I bring these terms up for a reason. It's highlighted for a reason. It would be a good idea for you to at least remember that an LSTM is a kind of recurrent neural network. But that's the only depth that you could possibly need. Finally, let's talk about the intersection of deep learning with AWS. So how do you actually deploy deep learning applications on Elastic MapReduce or on EC2? Well, Elastic MapReduce supports Apache MXNet out of the box, and you can also set up EMR clusters using GPU instance types, which is really important. So as long as you're running MXNet, and you can run TensorFlow in there too if you want to, and you have GPU instance types, you have a cluster that's coming out of EMR that is highly optimized for doing deep learning. You just need to know what kind of instance types to choose. So remember, if you're going to be doing deep learning, you want to be using instances that have lots and lots of GPU horsepower, because GPUs are really well suited for processing neural networks. Some choices might be the P3, the P2, or the G3. These all have various combinations of NVIDIA GPUs that are very good for accelerating deep learning neural networks. There are also deep learning Amazon machine images available in EC2, so if you want to build up your own cluster without using EMR, that's not too hard to do either. So that's your deep learning crash course and how it intersects with AWS. Again, you don't need a lot of depth on how deep learning works. You just need to understand the terms and how to actually efficiently deploy that on AWS.